Hi everyone. So today I want to talk about how I made my LED cube. So I have it right here. So you'll kind of be able to see it from my camera. Um, Here's how I made it. I have an Arduino Uno here, and then 16 wires going from the pins. Let's see if I can hold better. Down here, and so then soldered all of the different pins from the positive sides of the cubes on bottom, and then I have four more for the ground cables right here. And I'll go more into depth and talk about that, but I'm probably going to use this as a reference because I have it on my desk here as I'm working on this. So the goal of this project was to recreate a 4x4x4 LED cube that can run different patterns of lights. It'll use the same color lights for all the cube, and I will have to make four layers of LEDs that are all soldered together. To do this, I would need to make a template to place the LEDs in so they would solder accurately and consistently. I would then want to connect the LED cube to an Arduino Nano. I ended up using an Arduino Uno instead, so I had enough pins to run the code. And then I'll use something called multiplexing, so less pins are needed. So that's why I have 20 pins instead of 64, because I basically use 4 pins to control what layer of the cube is on through the ground signal, and then I use a 16 for each vertical layer or vertical row. So like it go like up. So you can kind of see like there'd be four here, and then you'd say like what layer. So you could get like what horizontal and then what vertical part of the cube you want. So then you can control all 64 pins with only, or all 64 LEDs with only 20 pins. So that was really nice. Made it a lot easier on the code. I did end up using some code from online from the guide that I found, and then I ended up just changing the patterns how I wanted because the main goal of this project was to get more comfortable with using wires, resistors, LEDs with soldering. So I didn't want to have to worry too much about my code failing or being messy or buggy, when instead I wanted to focus more on the physical part of it. For my next project, I'll talk about it a little more at the end of the video, but I think I'm going to plan on writing all my own code for it just so I can learn about connecting the two since I've done kind of some software and hardware at this point. But so section one, I wanted to test the LED on a breadboard to see which resistor would be appropriate. Most LEDs you can use a resistor between 200 and 1000, and the resistors I settled on were 430 ohm resistors. I think that might have been 200. Both work, but the idea is you need a resistor because if you send just the straight 5 volts positive signal to the LED, the light could burn out and you won't get a signal from it. So that's why you need a resistor. I also needed to find some cardboard or wood to drill the little holes that were the size of the LED heads into the template. So what I ended up doing was getting cardboard and I drilled 16 holes with a drill bit that was small enough so I could place them into that little template and make the 4 different layers. And you'll see a little bit more of that later. I also needed to find the right drill bit and then practice soldering before the first layer. So when I first got my soldering kit, I tinned the iron tip and then just kind of played around with it with a few pieces just to get used to it. I think I definitely learned a lot about soldering through trial and error. I messed up a lot and had a lot of frustrations with it, but I think it kind of helped teach me a lot about it and was a good lesson to learn. It was really good practice. I feel confident doing other things with it now, which is good. So here's kind of my setup. I'll zoom in a little more. There we go. Um, so I was in my kitchen. You can see the drill. Here's the cardboard I used. I ended up cutting it so it's smaller so I could move it around on the table more. But I drilled 16 little holes in there, and you can see a little breadboard that I test with. I need to order a bigger one. I'm using my larger one for another project right now that I was doing over the school year that I haven't taken apart. But yeah. So section one reflection, ended up using 470 ohm resistors. I ended up using the side of a cardboard box that I got, and I found the smallest drill bit that I could that the LEDs would sit in, and then my next thing was I was going to drill the 4x4 grid. So section two, the first layer. This was probably one of my biggest challenges with the project was designing and getting that first layer made because when I found better methods or ways to do it with the first one. And I found what kind of worked for me. It was really easy to replicate that 3 more times. It was just time consuming, but not as hard. So I wanted to drill a 4x4 grid of evenly spaced holes to place the LEDs. I wanted to have a quarter of LED legs to overlap to solder easier, just to give it so there was enough room to put the solder between the LEDs and make sure they would connect properly. And I folded the cathodes of the LEDs horizontally to solder together each layer. So this would be the ground signal that would go to each layer, that you would see on the cube. And I soldered 4 rows of cathodes together, and I soldered 2 long wires perpendicular to other legs to provide better base to the layer. And I wanted to test the LEDs by using a 5-volt ground wire and resistor to test if all LEDs are connected. So this is kind of what one of the layers look like. So as you can see right here, if you kind of look at my cursor, these 2 wires here were soldered on after the 4 rows were made, and they are not made from like the negative legs of LEDs, because the 4 rows and negative legs all solder and stick together, and then I had to cut this other wire and solder it on here. And I initially had aluminum wire, and that was harder to solder with, so I ended up buying a silver plated copper wire, and that ended up working better for me to solder with. But yeah, so here you can kind of see I have the ground signal here because it connects horizontally, and then I have the positive signal, or the positive wire, go and touch the tops of these LED legs, and I would make sure that every light would pop up. So normally, when you would put the ground signal at the end of one of these, it should still work over here since this wire is connecting across, and it should give the ground signal across to every row. And I had a lot of trouble with soldering it working, and then coming back to it, and it didn't work, so I had to resolder these joints so many times. That was probably the most tedious part. The most frustrating part was going back and having to redo stuff over and over. But definitely taught me better techniques for soldering for this stuff, which was, learning experience. Reflection. So I should have ordered LEDs with longer legs. It kind of worked in retrospect, later, because I ended up being able to place the Arduino on this prototype board, because if this cube was bigger, this wouldn't have fit on it, and I would have had to make something else to do that. So I'm kind of glad that it was this size, but for soldering purposes, it was harder when they were so close together, because you could get LEDs with longer legs on both, for both the positive and negative, so then they'd be more spread out and it'd be easier to get in between them to solder. And the cube will be more condensed than I thought because of this. The LEDs are 1 millimeter apart from each other on each layer. The drill holes are as close as possible, but should be fine since I'm making 4 layers from the same template. So yeah, that's why you can kind of see on this cube, it's not totally, I'm trying to get it. There we go. It's not totally perfect in how they're cut out. It kind of leans a little, and it's a little misshapen. But since I was using the same template for each layer, it did stack up properly, even though it wasn't perfectly measured. So it did work out. And then testing the ground and positive worked for each LED, so soldering was fine after a while. I struggled with soldering the 2 support wires on the sides of the layers. Like I said, soldering like the resistors and LEDs together was not really a problem. It was really just like getting those wires onto the LEDs. Section 3, finishing the layers. So at this point, I wanted to make 3 more layers with the same steps, test them each to make sure soldering and LEDs function correctly, and then connect the vertical legs of the LED layers using crocodile clips and cardboard cards to prop them up, and solder vertical legs to each layers. So at this point, I put one of the layers inside of the cardboard jig that I made, and then I cut out these 2 tiny little cardboard strips just to prop up the next layer, and then I would crocodile clip the 4 corners, so it would be here, 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 and here, and I would take one of them off and then solder that end, and I would kind of work my way around to the inside of it, because that helped me get the most support out of the cube and make sure that it wouldn't break when there was only like 1 or 2 joints soldered. And this honestly went easier than I thought. I thought I'd have more troubles with this. So, like I said, to reflect here, repeating making the layers helped me learn a lot about soldering. Like I said, very time consuming, but getting in the habit of making multiple layers and doing the steps over and over helped me kind of refine my soldering and learn about the best ways to do it. Because I think if it was kind of like a one and done thing for each of them, I might not have learned as much from it. I had troubles getting the supporting wires to link the rows, but found out easier ways to solder them. Like I said, I kind of use the crocodile clips to kind of push them. Like once I got the initial solder on, I would reheat them and push them together more, and that was more useful. I think that worked out better for me. Like I said, just very time consuming. That's kind of the theme of this video. I also had to go back and resolder old layers, and some of the rows stopped lighting up as well due to my poor soldering skills. Soldering vertical anode legs was easier than I thought, like I talked about. And one of the solder joints got disconnected in the middle of the cube after, though, which is hard to fix after the layers were on top. So yeah, that's why I was hesitant to solder the whole thing together right away when I knew the joints were still kind of iffy, because it made it so going into the middle layers, when they were soldered together, was really hard to solder. So I was kind of putting that off for a while. But at this point, I wanted to wire everything to the prototype board, which is this giant green board that you see that everything is on, and to the Arduino. So this is kind of where I put everything together. So I wanted to solder the bottom cube legs to the prototype board, cut off extra wires for the ground cables, solder one wire per layer to each of the grounds, solder resistors to prototype board, solder wires underneath the prototype boards, and hook up all the wires and pins. So I kind of worked backwards of the guide that I followed. I ended up putting the resistors away from the LED cube, and so I got these like adhesive. I got this like adhesive pad that I cut up and put to the Arduino, so that's how it's sticking here. It's not like hot glue or anything. And then and it's kind of like a little pad, so the parts under the Arduino aren't affected by it, which is nice. And then, as you can see here, I have 16 resistors kind of at the bottom here. And then these yellow wires go straight to the 16 positive pins for the LEDs. And so that's kind of how you see them soldered here. And then you kind of see this gap here. That's where the resistors are at. And then these are the other sides of the resistors that go to the positive pins of the LEDs. So I made it so there was more room to put these back end wires, and I think that made it a lot easier to do that, because if I put the resistors all in here, I think it would have just been a lot messier. And especially since I kind of moved everything around like this, I'm definitely happy how I did it. And then kind of like I said earlier, there's these 4 wires here. So I had it so the wires kind of stuck out on the ends here, and I don't know if you can see, it's kind of bright, but I kind of tilt it so you can see. These 4 wires stick out and go under, and those basically act as the ground signals. And so I have one of them go to each layer to basically act as the ground signal to say which layer you want on at that point, to control it. And then these 4 wires go to the analog in ports on here. Most of the pins go to the digital ones for the positive ones, except for 2, since I ran out of room, went to the analog in. They went to A0 and A1 on here. But yeah, overall, like, so I was honestly like really surprised yesterday when I soldered all of these together and 90% of the cube just worked. There's one vertical column that is just always lit up, and I don't know why. And I think there's 2 LEDs that just burnt out and didn't work on me since I was just soldering them so much. Must have hit the bulbs or something or broke them. But at this point, I don't think I would be able to go back in and resolder it, because I'd have to resolder the joints inside of it, and I think that would just be more dangerous to break other things than fix it. But overall, works pretty well. I'm really happy with how it came together. And so yeah, here's some pictures of it. I was kind of showing you on my camera. Here's parts of it lighting up, and here's kind of the back end of it. And I had this all hooked up to my laptop on kind of like a workbench. I ended up moving from my kitchen to a spare bedroom because I was kind of getting in the way of everything. But so kind of talked about this. Soldering was still challenging, but by this stage. And okay, sorry, mom came in there. So that's for reflection. Soldering was still challenging, but by this stage, I reinforced the more useful techniques that I learned through trial and error. I was honestly surprised when most of the LEDs worked when I ran the test code. I plan on using the template code and then making my own patterns for the cube. For some reason, one of the columns is slightly lit up in the program, which is definitely a soldering issue, not a code problem, because it kind of flickers like the joint is weak or something. But I don't know if it got connected to something else or what causes it. I'm I don't know. I'm still kind of tinkering with that. And for my next project, I hope to use 3D printed objects for better bases to put my parts on. I don't like that all of the wires and soldering is just sitting on the ground because I've already noticed a few of the wires have broken off of it already. So I'm definitely gonna work on that in the future. And one row does still not have a working joint. I think I went back and soldered and fixed that one already. I think it was one of the rows on the top, but I got that. And so, yeah, to fully conclude, this project became a lot harder than I initially planned due to soldering, but I did learn a lot about electronics, soldering, and conductivity of just electricity in general through this project. This is a good gateway into hardware focused projects as there weren't that many complicated parts or pieces, just reinforcing a lot of strong ideas about one piece, which is the LEDs. I plan on using 3D printing for future projects and possibly LED strips to make the soldering less messy because I know there's ways for LED strips to um, basically you can control them all through the whole strip while you only need to solder the ends of them. And I really enjoy working with Arduino, and I'm definitely going to use more parts than just LEDs in the future. I'm thinking about for my next part designing some type of box and printing it out and putting the Arduino inside of it and putting LED strips on the outside and then having it react to sound. I think that would be a good way to kind of mess with some 3D modeling and maybe reinforce my own stuff. And I also, it was mostly hardware focused, so I didn't fully write my own code. I just used stuff that was online for the guides, but I did write my own patterns. So you saw in the demo a few different patterns. This one that I have up here, which you're probably wondering what this has been. Basically, there's 16 of these little bees. And so basically, it's B and then four numbers. And so the four numbers, one represents the LEDs on and zero represents the LEDs off. So these represent 1 through 16, the different rows of the LED. So this one, it's called row test. So like I basically flash one row of LEDs on one at a time. And so this one was good because it made me test to make sure that each LED was working properly. Um, and so then in my other patterns, I just kind of look at, would write a few lines of the pattern, test it, and then see how all of it went. But this code down here I pulled online. It's not super complicated. Basically, you just have an array for your LED pins and your plain pins, and you can swap these out based on what order they're hooked up in here, so they're read in the right order. That's why mine are kind of backwards because I ended up, for each set of four, I ended up soldering them backwards from the order that this code was in. And so then you can change like what time it's at, and it keeps track of like what pin you're on, the index of it, and there's just a little bit. It's not super complicated. I was just worried about how I'd write the code, so I ended up using stuff online because I was unconfident in how the final cube would work. So I just kind of wanted to use some code that other people wrote for guides that I was kind of following. But for my next project, I plan on fully writing the code and doing the 3D printing just to kind of connect everything a little better, and so I have a little better understanding of it. But thank you for watching and listening. I really like this project. I really like seeing the feedback, I guess just visually, or like a real thing that I can touch and that I built. I think that's really satisfying. So I hope I can write code and keep doing stuff like this in the future. So thank you.